Hello everyone. Today I'm gonna represent my term project of CSA 454 data mining. Let's download the code. Okay, it's downloaded. Let me upload to the collapse. Okay, please we upload. As you can see, it is uploaded. Also, we had to put dataset. Let me quickly put the dataset. Okay. Okay. Okay, I put the dataset is here, as you can see. Let's begin. In this project, I developed a machine learning model using a naive-based classifier to predict student depression. The dataset contains demographic, academic, and lifestyle-related features. The first step involves loading and exploring the dataset, handling missing values, and encoding categorical variables properly to prepare the data for modeling. Okay, let's go to data loading. The dataset is loaded using pandas, and like that. After loading, the first few rows of the dataset are displayed using print df.heat. Okay, let's look. Here is the dataset. As you can see, this is the first 5 columns. Okay, let's explore the data. To get summary, we use df.info. Okay, here is the df.info. Here is the data types and how many of them is displaying in here. Okay. Also, it shows missing values. As you can see, for financial stress, there is 3 missing values. Okay. Let's handle the missing values. Number of missing values is small, so we fill it using the mean value, as you can see. Okay, mean value is this. Okay, now there is no missing values. Here are the categorical features and numerical features. Okay, let's go. Let's other part. Okay, let's move on to explore data. Here's the profession. Oh, sorry. Here's the distribution of dietary habits: healthy, moderate, unhealthy. Also here, distribution of degree. Okay, let's begin here. Gender, male and female. Cities. Distribution of profession, also there is only student. Distribution of sleep duration. Distribution of degree. These are the here are the unique values for these categorical features types. Okay, let's plot the distribution. These are the numerical type of datas. ID is not will be using, but we represent it here. Distribution of age. These are the distributions, as you can see. Okay. I defined a threshold for high cardinality and low cardinality for unique values, because I will use them for encoding. High cardinality values will be higher than 6. Low cardinality features will be smaller than 6. There is only 3 high cardinality feature: city, depression, and degree. I will be using frequency encoding for high cardinality features to city, profession, and degree. And here is the code for that. It's calculate the frequency and then making the encoding. Okay, frequency is applied, and also I uploaded the one hot encoding for low cardinality features. Let's start it. Okay, let's move on and display the first 5 rows of the encoded dataset, and we will get summary of encoded dataset. Let's run it. Okay, here is the result. There are a lot of features and columns. As you can see, here is the encoding. You can see it. Binary encoding is here. Okay, let's move it. In here, I dropped the ID column because we will be not using, because it's meaningless. Let's run it too. Here's the result. Okay. Okay, let's run it. In here, I will use standard scaler. I am standardizing the data because for nav-based classifier, I need a standardization data. So I use standardization. Okay. Okay, let's move on. In here, I defined the nav-based classifier class. Let me explain this class. Self.classes stores the unique class labels found in dataset. Self.mean a dictionary that stores the mean of each feature for each class. Self.variation this is the dictionary stores the variance of each feature for each class. Self.priors this stores the prior probability of each class, which is a proportion of samples belong to that class. Okay, let's go to the fit method. In here, it get the number of samples and features, and then it find the unique class labels in target variable. In this for loop, in here, it extracts all samples that belong to the class C. Then it compute the mean for each feature in each class C, and then compute the variance for each feature in class C, and then it compute the prior probability in here of class C. Okay, let's go to the other method, predict method. Okay, these are the very simple method actually. In here it use list comparison to apply predict single to every row x in x. I will explain this predict single later. It converts to the list of the prediction into a numpy array before returning. Why use predict single? Because each sample is classified individually, and predict single x determines the most probable class. Okay, let's go to the predict single. Here posteriors, it creates a list to store a posterior probability for each class, and then the loop computes the posterior probability for each class in this loop. In here it computes the logarithm of the prior probability, and then it initializes the posterior probability with prior, yes, as you can see here, and the inner loop it iterates over each feature in sample as the log probability of feature given the class using calculating log probability. Finally, the function returns the class with the highest posterior probability using np.argmax posteriors. Okay, let's go to the final method, calculate log probability. These functions just calculates the log probability of a feature belonging to a class using Gaussian probability density function. I will put this formula in report. You can check it in report. Okay, let's run it. It will run, and then let's train the data. It fitted, and let's predict test sets. Okay, let's evaluate the performance. Here is the accuracy, precision, recall, and F1 score. They are very, very low. You can check it. This is bad result because why? Also, I implemented cross-validate method. Let's run it too. It calculates recall, F1 score, and accuracy and precision. Also, these results are bad. Even we applied 5-fold cross-validation methods. These results are best because there are a lot of features, as I said. So I implemented PCA from scratch. You can see, and let me explain this function, what it does. Self.end components, number of principal components to retain after transformation. Self.mean stores the mean of the each feature needed to for centering the data. Self.component store the principal component. It is actually eigenvectors. And explained variance. It stores eigenvalues which indicate how much variance each component explains. Okay, let's move on. Let's go to the fit method. np.min it computes the mean of the each feature, and it centers the data by subtracting the mean from each feature. These steps ensure that PCA finds the direction of the maximum variance without being affected by feature magnitude. Okay, and then step 2, compute the covariant matrix. It computes covariant matrix where each row is a sample and each column is a feature. And these steps captures the relationship between features. Okay, step 3, eigenvalues represented how much variance each principal component explains actually, and eigenvalues are principal components and NIF features axis I mean. NP Lie length egg covariant matrix it computes eigenvalues and eigenvectors. Let's go to step 4. First, it finds indices of stored eigenvalues in decreasing order, and then this number of components in here. Okay, it stored exponent variance for later, and then select the top n component, and let's go to the transform. Let's go to the transform method. It centers data again by subtracting the mean. That's it actually, and it project onto the principal component using matrix multiplication. This reduces the dimensionality while keeping the most important information. Okay, let's go to fit transform. It computes principal component and calls a transform to reduce dimensionality, returns to transformed dataset. And last function, actually it is not of the part of PCA, but I want to know future importance, so I added to this class. Okay, let's look what it does. It calculates the absolute loading scores, and then it's summing across components gives a single score for each feature. Higher scores indicates that the feature contributes more multiple principal component, and then it's basically create data frame for better visualization. And then let's run it, and then let's run for number 9. I actually I use it different parts for PCA. Let's initialize nav-based. Nav-based trained on PCA transformed data. Let me make cross validation again. Okay. As you can see, after PCA it makes higher performance, accuracy, precision, recall, and FP score, because it eliminate the features has minimum information. Okay, let's go to the feature importance and study satisfaction and financial stress and academic pressure. These are the very important features in depression, as you can see. Also, I plot the script plot, and these are the 9 PCA, and these are the variants. Each variance has much more information. It has actually. I also plot PCA versus PCA2. It didn't give the good result. In here, I also write the code, but these are the pass codes. I used only one hard coding, so result very bad. Accuracy was very low when I print the features importance. I understand why, because there is a lot of unique values in category features. So I decided to change my approach for encoding. I stored codes on above. Yeah, actually, I start the project from start. These are the passcode. These are not that important.